Good morning or good afternoon. It's wonderful to be in Korea today and wonderful to see so many people. My name is Florian. I'm working for Andes Technology. We're a Taiwan-based IP company, and today I want to give you some introduction about RISC-V and how you can have a fast start for your SoC. Before we are starting, I first want to clarify some words. What is AIoT? AIoT, we at Andes understand it's artificial intelligence and Internet of Things. So the AIoT is needed for the edge. When you're doing more computation on the edge, when you not send all the data into the cloud, but you do it more on the corner. More important question from my point of view is, why should you use RISC-V? Why not go with another established architecture? Well, RISC-V is a clean slate architecture, so you don't have any legacy. It's very easy to use. You have a well-defined standard with a common baseline, like the I or the E baseline, and then you have modules you can add. If you're adding certain modules or you leave them away, it's not breaking any compatibility. Your system still can run and your system is still compatible with the whole environment, with all the support from Linux, from GCC and other things. Very important thing about RISC-V from Andes point of view is that you have the possibility to add custom extension via the domain-specific acceleration, which is defined in the RISC-V spec. That means if you're making an artificial intelligence chip, if you're doing something very special and you need to have your own custom instructions, with RISC-V and with Andes, it's very easy to add this into the core. And last but not least, RISC-V is supported by major industry player, by academic, but also a lot of hobbyists. That means it's a big movement, a big momentum, and it's pushing forward the standard. That will ensure, if you're going today for RISC-V, it will make it in the future a bulletproof investment and help you to leverage this. Let me give you a very short introduction about Andes. That's the only marketing thing I will have, I promise you. Andes Technology, we are a 14-year-old company, almost 15 years. We have around a little bit over 160 employees. And last year, in 2018 alone, we have shipped 1 billion cores. So we and our customers together, 1 billion cores, that's quite nice. Why we are coming into RISC-V? First, we are a founding member of RISC-V. We are also actively contributing, so we are a major contributor to a lot of tools in the Linux environment, but we are also a maintainer of some Linux like GCC. RISC-V is for us very important because it aligns with the values of our company. Let me give you a short overview what we are doing. In the upper left side, you see the Andes cores. That's the main thing we are doing. Then on the top side, you are seeing the Andes architecture. That's our added value we are bringing onto the cores. I will explain this in a little bit. And we also offer Andes Site, which is a software tool, Andes Shape, which is a development platform, so you can get our RTL and you can start developing very fast and very easy. And then also we have the Andes Software which is a software stack ranging from bare metal access over real-time operating systems up to the Linux BSP for very easy usage by you. What is the extension of the RISC-V Andes is providing? So first, we have the performance extension, which gives you more performance to your core. Then we have the Codense extension. With the Codense, you can have 12% smaller code compared to standard GCC. That means if you take the RISC-V compiler from GCC, you compile a code, and then you take our Andes GCC optimized compiler, your code will be 12% smaller. But you can take our compiler or the standard, the code will run on our CPU core, no problem. And then the Andes custom extensions, that's our framework for the DSA as defined in RISC-V. And we will deliver a very easy to use tool, so you can add your custom extensions. I will introduce this later in a little bit more detail. Just give you a short look into our roadmap. I don't want to spend too long. So on the left side, you see our 32-bit offering. and we are starting with a core called N22. So that is our smallest core. It's available in an embedded version with 16 general purpose registers, or in the integer baseline with 32 general purpose registers. So we have the N25 if you need a little bit more power. So that actually compares roughly to an M4 from ARM. You have the A25, which is adding a memory management unit if you want to run some basic Linux application for housekeeping tasks. And then the A25MP, which stands for multiprocessor, up to 4 cores with L1 cache and I/O coherency, as well as L2 cache added. On the right side, you see the same offering we have for 64-bit, except for the very small core. What we will release later this year, so there's a RISC-V conference in Santa Clara, US. We will release some cores with higher performance and also out of order. Let me show you our core, the N22, which is the smallest and most power efficient core. We are having a 2-stage pipeline with a single issue. We have configurable multipliers. We do have optional branch prediction, which you can activate or deactivate. There is iCache optional. The bus interface is AHD Lite or optional APB. And this program is also available in a free starter program. So that means you can go to the Andis homepage, you can click on a form and you can download the core and start developing or playing directly with the core. If you want to take it out, we also do have a free starter mass program for this. With the free starter mass program, we are also offering you some peripherals. So you have not only the N22 core, but you do also have a bus matrix, an APB bridge with some GPIO, real-time clock, quad SPI, and UART to connect easily peripherals. And what you see on the green boxes, there is where you can add additional accelerators if you want. If you are looking on our 25 series core, which is our medium range working horse, this is a 5-stage pipeline, single issue. We again have configurable multipliers. Configurable means that when you license our core and you get the RTL, which is Verilog handwritten to have it more optimized, you will also get a graphical user interface where you can configure your core and where you can change. For example, the multiplier, you can configure it to be very fast, let's say in 2 cycles, but it needs a lot of gate count and logic. Or if you're concerned about space, you can configure it to be more slow, but need less gate count and smaller space in your SoC. The same goes for the branch prediction. You can configure it to be just a very simple branch prediction, no branch prediction at all, or to be very fine granulate. The interesting thing about this is with the graphical user interface, you can change the behavior of the core immediately, compile it new, and test on your FPGA or test in the simulator directly. So there is no waiting for us to do anything for you. You, as our customer, configure the core by yourself directly and test immediately without losing any time waiting. For the 25 series, the instruction and data caches as well as the local memory have optional ECC protection. We do support hit under miss caches, and we have hardware unaligned load and store access. The bus interface is here AHD or AXI in various bit versions. Also for the 25 series, we are offering a platform. So the platform on the 25 series is including a platform interrupt controller. It is including the debug interface as defined in the RISC-V specification. And of course, we have again various IOs for a very easy connection of peripheral. Also optional, if you want to use, there is a DMA controller integrated. RISC-V P extension, that is something Andis has contributed to the RISC-V environment. So before Andis started making RISC-V, which is only 3-4 years old, we have been making our own RISC products, very successful, we still sell them. And we have integrated some DSP functions. These DSP functions are especially for some low power applications, for example, face recognition, where you only have 3-4 frames a second, or voice recognition, where your device is sleeping and a small processor is listening for some keywords to wake up the big device. The DSP extension, like I said, was developed by Andes. It was before in our proprietary devices and it was kind of closed source. But with RISC-V we have decided to open source it, make it available for the RISC-V community, so also our competitors can integrate it, and they will start hopefully soon. Interesting thing about this DSP is that you can use the standard general purpose registers, so you are not introducing new registers, therefore saving gate count in your final application. Let me show you some numbers, how this can speed up your device or your application. If you're looking for, on the top, 32-bit version, an MP3 decoding on a 32-bit with the DSP or the P extension on RISC-V, you can speed up by 1.8 times. AMR voice codec, like it's used in mobile phones, for example, you can speed up by 3.6 times, and keyword spotting you can speed up by roughly 5.3 times. If you're looking for a 64-bit system and you go for a face detection, you still can speed this up by 7.5 times. And if you're looking for a Cipher 10 image classification, where you get an image input and you need to define or detect 10 different categories like dog, horse, car, then you can speed this still up by 11 times. So we think at Andes that the DSP or the P extension, how it's called in RISC-V, is really a big benefit for low power applications. The next one is the Andes custom extension, and that's where we are giving our customers, or you hopefully, the possibility to very easily add custom extensions to your RISC-V design. Andes custom extension is a framework for supporting the RISC-V domain-specific architecture, and we are having a tool for it called Copilot. I will introduce it quickly, but before I introduce, let me show you some numbers for speed up. Like with this IoT age, you have a lot of messages going between different devices, and you want to make sure that all these messages are genuine, that there is no corruption of the message or something. For this, you're building some checksum, like CRC32, for example. And with our Andes custom extension, you can speed this up by 162 times. What does this mean? To give some more deeper example, if you're running this code in pure C program, it will take 480 cycles roughly. If you're making a custom extension, it will take 3 cycles, including fetching from memory and writing back. Therefore, a speed up from 162. If you're doing an inner product of vectors, which is used in neural networks a lot, then you can speed up with a custom extension by 84 times. How is it working? First, Andes will provide you the CPU RTLs, that is Verilog as mentioned before, CPU instruction set simulator, and also some assembler and disassembler. Then we also will provide you the tool Copilot, and the Copilot tool, you can tell very easily what you want to do. So you give your Verilog code for your function you want to execute. You give some C code which tells the compiler how the function should work. And you give some attributes like it should be scalar or it should be vector. It should operate in the background, or it should first write back before it's finished. You can define wide operands. That means if your CPU is 32-bit, you still can use 64 bits input for this. You can use 90 bits, 512 bits. You are very flexible with this. What Copilot does is then generates the extended RTL, instruction set simulator, and also the extended tools. But more importantly, it automatically combines all of these things together. So that means in the end, you will have your ready-to-use CPU RTL code combined with your custom instruction, and you only need to write the function of your custom instruction in Verilog, and all the rest, integration into the RTL of your CPU, the integration into the pipeline is automatically taken care by our tool. As well, as an assignment of an opcode for your instruction. So it takes you off a lot of work you normally would need to do by hand. So that was the introduction about the Andes core and the architecture extension we are having. Let me very quickly give you an overview about the hardware. So first, our Andes side, that's the software development environment we are offering you. It is based on Eclipse. It is integrated with our hardware. We are providing some FPGA development boards for an easy start for you, so you can start developing directly. In our Andes side, you also have a CPU simulator, so you can simulate in software if you don't like to touch hardware. It has a managed build system inside, source level debugger, flash ISP, and all of this integrates together and works together. Let me show you some overview from the Andes side. What you see in the top middle, for example, is a profiling option. Here we can profile programs and see where is the hotspot in the program, where does the program need the most time to execute. If you have identified this hotspot, you then can write a custom instruction to speed up and to make this more fast. On the right side, you see, for example, how you easily can construct the flash ROM via drag and drop. You still have the possibility to edit in source if you like to do this, but you also can do it by drag and drop. On the right lower side, the Andes side is also aware of real-time operating systems, so we have ThreadX, FreeRTOS, and many more. You just name it, we should have a VSP for it. And in the middle lower part, because it's based on Eclipse, our customers can write their own plugins for easy testing, for easy integration. The middle lower part is an example from one of our customers. He was integrating some analog part and he was using the access to the memory directly to have some real-time debugging of his analog part integrated with our core. That's the hardware I have mentioned before. You see we have various FPGA boards depending what you're developing, from a high-end FPGA board with DDR3 RAM on it, with SD card interfaces, VGA card interfaces and sound, up to a lower one with with wireless interface for low power networking. We do also have our own debug boards, the ICE Micro and ICE Mini Plus, which you can use to debug our cores. As we are following the RISC-V debug specification, of course you can use also all the other debugging boards, but it's just handy if you get everything from one hand so you know all the tools work perfectly together. And of course our tools also supported by third parties like Lauterbach and Sega. For example, Sega just has announced recently, a few weeks ago, that they are fully supporting our 25 series CPUs. So that means now you can use the Sega tools to test, to debug our cores. With the Sega you have an ultra fast download from 1.88 megabytes into the RAM here. And Sega is also offering an embedded studio in case you don't like our Andes side. But I promise you, if you have tested it one time, you will love our Andes side. By the way, if you're for academic use, the Sega board is also free. Okay, so summary, AIoT requires ultra-low power devices, and we are at Andes offering industrial high-quality RISC-V CPU IP. We are a pure-play IP company on the market since 2005. We are silicon-proven. Last year we have shipped 1 billion of devices. We have leading PPA and code density size based on real feedback from our customers. Advanced and comprehensive tools, I just have showed you, so you can have everything from us. And we have rich software toolchain expertise, as we are also contributor and maintainer for some of the major tools used in RISC-V. So to make it short, Andes is your trusted computing expert and hopefully your best partner for RISC-V. So I want to say thank you very much for your attention. My colleague and also our sales from Korea, we will be on the exhibition oversight in the IP pavilion. So please come over, talk with us, and thank you very much for your attention.